Questions like, what's your favorite class? What's your least favorite class? What, on a scale of 1 to 10, what do you rate math? What do you not like, or what is hard about math? And I looked through those during the break just to see. It gets, honestly, I didn't look at them right when you gave it to me because I didn't want to be skewed in what I thought you liked or didn't like. So I looked at them during the break, and it's interesting because a lot of you, on what's the most difficult part, you said dealing with fractions and decimals. So yes, multiplying or even adding and subtracting fractions can be a little bit tough, but the thing is we got to get more comfortable with those. And hopefully as we go through this lesson, I hope to build your confidence in understanding multiplying fractions, okay? So we're going to go to our first example to start off. Example number 1. Solve x equals 5/12 times 2/9. All right, so here's your equation you want to solve for x. And what is the rule when multiplying fractions? What do you have to do? You have to do this. When multiplying fractions, you don't need to have common denominators, which is nice, right? You don't have to get common denominators, but you do have to do this. Josh?
Don't you multiply across?
Multiply across. You multiply the numerators, multiply the denominators. Now, there is another thing you can do, but I'm just going to go ahead and do straightforward multiplication. What's 5 times 2? 10. 12 times 9? Wow. You know, usually when I ask 12 times blank, I get an awkward silence. 12 times 7?
84.
There we go. That's that awkward silence. That's okay. That's okay. But that's what I get. When I give a 12 times something, I get like a blah. And sometimes it's correct, which is good. Sometimes it's not. But please get comfortable with your 12s because you see it. But is this my answer? No, because it can be simplified. It can be put in simplest form. So what goes into 10 and 108 evenly? What number goes? Oh, Dave's 2. So 2 goes into 10 5 times. 2 goes in 108 54 times. So x equals 5/54. Now, if you're looking at that, and this is where I want you to understand what fractions really are, can anyone tell me what that number is approximately? What is 5/54 roughly? I'm not saying exactly. What is it about? Because when we look at that, don't know what that means. But what is it about? Maybe easier number. Sarah?
0.10.
Okay. 0.1? Yep. I could say 1/10, 1/11. Isn't that close to 5/55ths? Or isn't that close to 5/50ths? Which is 1/10 or 1/11. Okay, good. Or 0.1. All right. But there's got to be an easier way to do this, right? And there is. We're going to work this problem out again. But this time we're going to do something before we multiply across. Do you guys remember that when you have a numerator and denominator pair that has a common factor, that you can cancel that out? And you're like, huh? Okay, maybe it's been a while. But do you guys see that? Is there a common factor between 2 and 12? 2 and 12. What's the common factor of 2 and 12? Be very careful here. Annie, what do you think? Common factor. 2. 2 is a common factor of 2 and 12. 2 goes into 2 one time. 2 goes into 12 6 times. So would you guys agree with me that 2/12 is equal to 1/6? Yes. Okay, so we're not changing things up. We're just making it easier for us. Is there anything else that's common? I found something. 6 and 9 have a common factor. But they don't. Oh, that's right. This is a common mistake. A lot of us know, okay, I know I can cancel those out, but sometimes we get really, really tempted to do this. Oh, doesn't 3 go into 6 and 9? And then we cancel those out? Are you allowed to do that? No. You can only cancel out a numerator with a denominator, not a numerator with a numerator or a denominator with a denominator. Okay with that? Because it's going to be very tempting. But wouldn't it make those numbers smaller? Yes, but it would also change the problem, which is not what we want. Yes, ma'am?
If it was 5/10, could you simplify the 5 and the 10?
Yes, good question. So I said a numerator and denominator pair, which a lot of times happens diagonally, but it can also happen vertically, here or here. Okay, so is there anything else to cancel out here? No. So what's 5 times 1?
5.
Ooh, that's nice. And 6 times 9?
54.
Huh. Have you ever been at a point where you see something that you felt like you've seen before? I feel that right now. It's like it feels like I've seen 5/54 before, and it's that deja vu feeling. Oh my goodness, that's why. Okay, did we get the same answer?
No. Yes.
Oh, good. Thank you, Nick. Yes, making sure that I'm doing this correctly. But yeah, did I get the same fraction? Okay, both of them will give you the correct answer. But why is canceling before multiplying easier? Why is it easier? Is it? Because I had to divide here. I had to divide there, so I divided them both.
But the small numbers.
Good. I'm canceling out, or I'm using smaller numbers to divide. And then here, didn't I get 10 over 108? And then I have to divide bigger numbers, so that is a little bit more complicated. Cancel or divide before you multiply here. So 554 equals x. Yes, sir?
Will you have to simplify if you do it the bottom way? Like, will you still have to simplify?
Okay, great question. You know what's cool about this method here? If you cancel everything that's common, you do not have to simplify. It's already simplified, which is cool, right? Because what was the common factor here? 2. What'd you divide those both by? 2, which is there is a relationship there. All right, let's go to example number 2, because sometimes you get mixed numbers, and sometimes they are positive and or negative. All right, so example number 2, we're going to look at A, and A gives me 3 3/8 times negative 5 1/3. Negative 5 1/3. And that equals, thank you, x. All right, so I'm trying to solve for x. What do I have to do to those mixed numbers before I just start multiplying across? I don't just want to multiply across. Betsy?
Do you multiply the mixed numbers?
Okay, so give me a little more specific there. What do you think?
Don't you multiply the big number, the mixed numbers first?
So the whole number?
You multiply those first, and then you multiply the fractions second, and then you put it together.
Okay, and that I think would work really well with addition or subtraction. But when multiplying, you actually want to do this first. Chelsea?
Change it into improper fraction.
Yeah, get these into improper fraction form first, then multiply across. So what would 3 3/8 be as an improper? Well, what's 8 times 3?
24.
24 plus 3?
27.
27, good. Sorry, I heard a couple things. 8 times 3 is 24, plus 3 is 27 over the common denominator. We're good with that. And what's negative 5 1/3 as an improper fraction? Go ahead.
Negative 14 or 16. Wait, would you add it to it because it's negative or no?
Oh, good question. Okay, that is a confusing part. So yeah, I have a negative, but here I can block that negative. What's 5 1/3 as an improper? 16/3, and it's negative 16/3. Yeah, so that's a good question. All right, so I get this problem. Is there anything I can cancel out before multiplying?
Yes.
All right, let's see here. Matt, is there anything you see that I can cancel out before I multiply? Anything that has a common factor? And I would say, as he's thinking, yeah, 8 and 16, you know what sometimes kind of throws us off a bit? That negative sign, right? But I'm going to ask you something real quick, and then I'll get back to the 8 and 16. What's a positive number times a negative number? Always, boom, go. Negative, automatically negative. So my answer is going to be x equals negative something. So I don't even have to think of the negative anymore. It's done. It's already in my answer. All right, but 8 and 16, all right, what's a common factor between 8 and 16? Nick?
8.
8, but isn't 2?
Yeah.
Isn't 4?
Yeah.
So which one do you want to use?
8.
I want to use the biggest common factor, and you took it from me. The biggest common factor. I want to use the BCF. Wait, it's not BCF. You guys remember?
GCF.
GCF. What's the GCF of 8 and 16? 8. 8 goes into 8. 8 goes into 16. Anything else? What's the BCF of 27 and 3? 3. GCF, thank you. 3 goes into 3. 3 goes into 27. Okay, little plug in here, commercial break. Multiplication tables, their value. How many of you would agree that if you know your multiplication tables, this is easy to do? Yeah, remember, okay, how about this? 12 times 8. 12 times 8. Okay, if you didn't know that, this is what would happen. You have 96 and 12, and you're like, okay, the BCF or GCF. The GCF is 2, and so you divide by 2. Then you divide by 2 again. Then you divide by 3. You did 3 divisions instead of doing 1, dividing both by 12. So is it important to know your multiplication facts? Because it really helps us to go quickly. All right, anything else to cancel? Anything else I can cancel out? Nope. What's 9 times 2? 18. And what's 1 times 1? 1. Nice. Negative 18 over 1. Notice I didn't circle that. Yeah, Peter?
Negative 18.
Yeah, x equals negative 18. So is negative 18 over 1 equivalent to negative 18?
Yep.
Yeah, but which one is the best form? Yeah, don't leave it as an improper fraction. Leave it as a mixed number, if possible, or a whole number, integer, I should say, for that. You guys get that?
What if you put in the circle negative 18 over 1 or negative 8?
Yeah, that actually I see that a lot from you guys. Like you put this or that. I'm almost wanting to say, give me the best answer. So give me the best one. So don't put an or. Just say, this is it, Mr. A, I'm sticking with it. If you get it wrong, I'll take a point off on your test or quiz. If you get it right, great, you got it all right. But I want you to be firm on your answers. But yeah, good question. All right, let's look at B. Example 2B. A is equal to negative 1 and 4/9 times negative 2 and 3/5. Negative 2 and 3. Okay. Before I even work this one out, the signs throw me off. I'm like, negative, positive, which one is it? Okay, what's a negative times a negative? Okay, let me try that again. What's a negative times a negative?
Positive.
Automatically positive. So listen, you're done with the signs. You already know the answer is going to be positive, so you're done. Don't worry about the signs anymore. It's going to be A equals positive something, and I'll put that just so we remember. How do I change 1 and 4/9 into an improper fraction? Park?
You just take the 1 and turn it to 9, and then 4 plus 9 is 13.
So 13/9.
Yes.
And then what about 2 and 3/5? Laura, can you help me with that? 2 and 3/5?
5 times 2 times 13 fifths.
Yeah, you get 13/5. Nice. And we know it's positive, so don't even worry about the sign. Common factors, yeah, 13 and 13.
No, not diagonal.
Oh. Or
Vertical.
vertical, yeah. Because you could do diagonal, but you can also do vertical. Can you do horizontal?
No.
Okay, so can I cancel those two out? So can I cancel anything out in this problem? No? Oh, man. So what do you think we have to do? Let's multiply. Now, this is a cool little thing we're going to go through. 13 times 13.
9. Or it ends with a 9.
It ends with a 9. 169.
Yeah, I knew that. Close enough.
This is I'm going to get to this because I'm going to show you something here. 9 times 5.
25.
Okay, that one you should know, hopefully. All right, we're going to stay here for just a moment. I know you can make it easier or make it simpler. 13 times 13. How many of you memorized that already? Okay, maybe a few of you. I'm sorry if you haven't. I haven't expected it. But I do have these that I want to ask that I hope you've memorized. What's 7 times 7?
49.
Good. 8 times 8?
64.
10 times 10?
100.
11 times 11?
111.
132.
121. So if you haven't memorized it, 11 times 11 is 121. 12 times 12. Okay, good. 13 times 13.
169.
Good. Now, the reason I'm even bringing that up is like, we didn't have to memorize our 13s, did we? No, usually you don't. But it's nice, and eventually you do. So I've memorized this not because I've sat there and done 1 times 13, 2 times 13. It's because I've done them so many times, I remember that from the past. I would say if you know this is good. Okay? Oh. Anyway, there's also another cool fact about this. I'm going to give you some more problems dealing with exponents. Do you guys remember exponents? Like something to the second power or squared. Okay, ready? What is 7 squared? 49, right? 7 times 7. What's 8 squared?
64.
10 squared?
121.
No, she was waiting for the other one. 11 squared.
121.
12 squared.
124.
13 squared.
169.
Okay, good. So you see how they relate? Okay, now, someone asked in the last class, I thought it was a great question. Maybe you were kind of thinking it, didn't want to ask. Why do they call it squared? Why can't they call it to the 2? Let me help you out with that. Because, I look at it, I'm like, why squared? And why cubed on the other one? Okay, ready? So I'm going to draw my best square. Please don't look. It's making me nervous. Yeah, don't be a critic.
Oh, that's good. No, that's bad.
Oh, man. Harsh. Thank you for the encouragement. Sorry for the... it's not perfect, but it's my square. Okay, the reason we call it 13 squared equals 169 is this. Geometry, right? Some of you love it, some of you don't like it. We'll see if we can understand it. Okay, if I had an area of this square, so I'm going to put A, if it equaled 169, okay, units squared, right? Or square units. You know what the length of each side would be?
13.
It'd have to be 13, wouldn't it? Because what do you know about a square? Equal sides, right? So what's 13 times 13?
169.
Okay, so you see how I get 13 squared is 169, or 169 square rooted. Have you ever heard of the term square root?
Yes.
Okay, so here, let me write this down because I want you to think a little bit more. I want you to think more than what this lesson, unfortunately, just goes through. The square root of 169. That's asking, what number times itself is going to get me 169? 13. So square rooting, right here, and squaring are inverse operations. They undo one another. Ready? Can I ask you a question? See if you guys get it. Ready, guys? What's 13 squared? 169. What is, and watch my pen, what is the square root of 169?
13.
Okay, so these operations, square rooting and squaring, undo each other. Okay, ready? Let's see if you guys can get this. Don't give me the answer until the very end. Don't say anything until I say it. Give me the answer. What's 13 squared, square rooted? So I'll write it down. Some of you are visual. 13 squared, square rooted. Don't say it yet. Go. 13. This right here and this right here undid each other, right? Okay. You actually did better than I thought you would on that, so that's great. I'm looking for an eraser. It's right here. Okay.
Whoa, that's...
Goodbye. All right. I do want to go back to the problem, though. So, do you understand that there's a reason why we say squared?
Yes.
What are we referring to? A square. Why do you think we call it to the third power cubed?
Because it's cubed.
You're referring to a
Cube.
cube, a third dimension, 3 by 3 or whatever, 13 by 13 by 13. It's a three-dimensional figure. But there is a reason. All right. Is this my answer?
No.
Oh, man. What do I do with it?
Simplify.
How?
Simplify.
Just make it like a number.
Make it a mixed number. How? Chelsea?
How many times is 45 going to 169?
Ready, guys? This is review.
Whoa. 13.
Sorry, I'll move. Isn't it division?
Yes.
All right, 45 goes into 169 3 times. And
What's the remainder? 34.
Oh, sorry, that is not it. It's 135. So it'd be 135, and then it would have a remainder of 34. So if you work this one out, what would be your complete mixed number?
3, 34, 45. 45th.
There you go. 3 and 34 45ths. So that would be positive, right? Because we said that at the beginning. 3 and 34 45ths. That's your answer. Now, I want to help you, and it's A equals F. I want to help you out with that because we talked about estimating, and there's a reason why I want you to think about it today. A lot of people, when they look at 3 and 34 45ths, they're like, I can't even say that, let alone understand it. But really, can you understand it?
Yes.
What is 34 45ths? Just 34 45ths. What is that about? What would it be about? Just the fractional part. Be worth about 3/4, or you can even say it's about 1, right? Isn't 34 over 45 about 3/4 or 1? So what's 3 and 34 45ths about? 4. It's a little less than 4, isn't it? So when you look at this number, don't be like, oh man, I don't know what it is. It's about 4. Okay, so that's what the number means. It's about 4. And that happens. You get a lot of those numbers that are about a whole number. Okay, example number 3. I like this example because it's very telling and it's very informative. Manuel Mendez is the chief cook at the U.S. Military Academy at West Point, New York. He and his 96 staff members work to feed 4,500 cadets 3 times each day. So it's a busy job. Their Sloppy Joe recipe calls for 7.5 pounds of ketchup and serves 100 people. 7.5 pounds of ketchup will serve how many people? 100 for their Sloppy Joe recipe. Okay, so that's a lot. Now, do you think they're going to need more than 7.5 pounds for these cadets?
Like 300 something pounds.
Okay, that's a great estimate here. Let's see what we're going to get. All right, I'm just looking at the number of pounds of ketchup they're going to use for Sloppy Joe. All right, how many pounds does he need for 100 people? 7.5. So they have 4,500 people. So what should you multiply that by? 45. Okay, I'm going to multiply by 45. Because 7.5 serves 100 people, but I need 4,500 people, so multiply times 45. All right, I need an estimate of what this is going to be. I don't need an exact. Don't give me the mister, I think it is about 337.5 pounds. Okay, yes, but give me an estimate and what you did to find that. Okay, Sarah?
Layer the answer. If you change the 7 into a, it would be either 9 or 5, because if you change 7 into a 5, then it'd be times 40. I think it was division.
Yes, and that's okay. That's commonly what that's okay. You know what? I'm going to make it easier for you guys. Ready? Can I do 8 times 40?
Yes.
What's 8 times 40? 320. So that's my estimate. That is not exact. That is an estimate. I'll even do it with a little cloud. That is not my answer. Okay, but how are we going to find the exact answer? Well, what do I change 7.5 to? Yeah, improper. 15 halves, or 15 over 2. And what do I change 45 to?
45 over 1.
Good. 45 over 1. Uh-oh. Is there anything to cancel out? Oh, the 15 and 45.
Nope.
Oh, nothing. So what do? Multiply. Okay. Don't be afraid of these numbers. You've done these before. 45 times 15. All right, so I'm going to multiply that out. That's not what I wanted. That's a new number, by the way. Okay, sorry. 5. Okay, so I get 5, 7, 6. 675. Okay, 675 over 675 over 2. Okay, is that my answer? Is that 675 over 2 pounds? No, you change it into a mixed number, because it's not going to go evenly, right? So divide that out. 675 divided by 2. Remember, it's a division problem. And then don't feel too bad. It's not going to be a decimal. You can keep it as a mixed number. So 2 goes into 6-3. 2 goes into 7-3 with the remainder of 1. 2 goes into 15-7. Remainder of 1, 0. Oh, I didn't even have to do that. 337.5. 337.5. What? Pounds of 337.5 pounds of ketchup. That's for one sloppy Joe meal for 4,500 cadets. So you're taking vats of ketchup and dumping them into a giant mixing bowl, and then that's the one. You see those tools he's using? Sorry? Oh yeah, Heinz is like, we love you guys. But anyway, you see those tools he's using? Those are big mixing tools. So you're like using your whole body to do it. It's a nice workout.
That's how I get access to be in the military.
Yes. So a lot of ketchup there. Okay, last example, and then I'll let you go for your homework. So example number 4 is nice. Example number 4 made the last class think a lot of great questions. If you have questions, ask them. Evaluate the expression AB squared if A equals 1.5 and B equals 2/3. All right. On this problem, I have to realize this. I have multiplication going on and what? Squaring, good. Or, yeah, no, you say, and squaring going on, or use of exponents. Do you guys remember order of operations? What do you do first? Exponents come first, then multiplication. All right, now I'm going to replace the numbers where they belong. So I'm going to put 1.5 for A, and then I'm going to put 2/3 for B, and don't forget that squaring, or the squared part. So that's what my problem is. You're like, what do I do here? Okay, what did we say you have to do first?
You have to make the 1.5 into
Okay, so yeah, you can do that if you want first. So you get 3/2 times 2/3 squared. Okay, so you can do that, but what do I have to do now? Order of operations. According to the order of operations, I must do this first. Davis? Okay, parentheses, like if there's anything in here to do or anything in here to do, then you would do that first, but that's all done. What's the next step? Exponents. I have to deal with this guy first. But I'm a little confused. What in the world does 2/3 squared mean as a multiplication problem? Anybody? 2/3 squared? That doesn't make sense. That's not even a... Wait. 2/3 squared. If you say it enough times, it comes to you. 2/3 squared. 2/3 squared. 2/3 squared. Parker, what do you do?
2/3 times 2/3.
Wait. Yes. This right here equals, so I'm going to rewrite it, 3/2 times 2/3 times 2/3. Isn't that what it means? So it's just a big multiplication problem. Questions? Any question on that? Because I want you guys to get this. Okay, and there are 2 ways to work it out. I'll show you another way after you do this. All right, so here you have 3 numbers being multiplied. Can you cancel anything out before you multiply? Is there anything that cancel out?
Yeah.
All right, someone help me out. Give me one thing to cancel out, Sarah.
The 3 and the 3.
So I'll go with this 3 and that 3, 1/1. All right, another thing to cancel out, Nick? The 2 and the 2. You mean like this 2 and that 2?
Yep. Yes.
Someone tell me why you can.
Because.
Jake. Oh, Jake. Did you steal my script? That's exactly what I wanted to say. The question was, can I cancel these 2 out? Yes, we did that. But can you cancel these 2 out? And the answer is?
Yes.
Yes, because you could have moved this guy over here and it would have still been the same problem. So that's fine. Yeah, so what's your answer?
2/3.
Whoa. No way. Yes. That's it. It's just 2/3. All right. Now, some of you may have worked it out differently, and it's totally okay if you did this way. But let's see if it gets you the right answer.
Is the answer 2/3?
I hope so. Okay. this is actually hopefully going to help you out with your understanding of fractions. Let me get to that in just a moment. So like, how can it be 2/3? How can this be just 2/3? We'll get to that. But here, another way to work it out is, does anyone know what 2/3 squared is? What's 2/3 squared? 4/9. Yeah, 2 times 2, 3 times 3. And what's 3/2 times 4/9? Well,
12/18.
And then what does that reduce to?
2/3.
So you still get 2/3, don't you? Either way you do it, you're going to get 2/3. Okay, now that answer isn't making too much sense to me, too, as I look at it initially. Okay, do you guys know what multiplication is? It's making addition shorter. Okay, so instead of doing 2 plus 2 plus 2, what's your multiplication problem? So you're like, yeah, here's.
Josh.
I'm a popular person, what can I say?
Would you like me to answer?
I don't know.
Sure.
Where's the phone?
Can you silence it? That'd be great. Yeah, Swivl. Sorry.
Swivl caught that on you.
Swivl doesn't like that because he likes to be the only technology. That's, yeah, just silence it so it doesn't distract. Oh yeah. What was I doing? 2 plus 2 plus 2. All right. Can someone write that as a multiplication problem? Yes, ma'am? Yeah, 2 times 3 or 3 times 2. Either way is good. So we say multiplication is a short way of adding, okay? What you just did was 1.5 times 2/3 squared. Okay. What I'm also saying is, what is 1.5 of 2/3 squared? That's a tough concept, but the word of in math means what? Of means multiplication.
If you're multiplying it by 2, then it would be 2/3, so you can figure it out from the very beginning.
Maybe. Yes, I think you're going deep there. That's a good thought. But what is 2/3 times 2/3 again? 4/9. Does anyone know, and this is a tough question, but you know the answer, even though you don't think you know the answer? What is 1.5 of 4/9?
2/3.
It's 2/3. Right? Isn't that what we worked out? Okay, another way of putting it is this. Isn't 1.5 1.5? Okay, what's 1 of 4/9? What's 1 of 4/9?
2/3.
4/9.
It's 4/9. Okay, hold on. What's half of 4/9? 4 18ths. Okay, you're like, okay, I don't know. When you add these two together, you're like, I don't know. This is your problem. What do you get?
12/18, which equals 2/3.
That's the answer. That's tough, guys. I really wish I had more time to talk about fractions because they're not as bad as you think. They actually, what's 1 of 4/9? 4/9. What's half of 4/9? 4/18. What are those two added together? 12/18 or 2/3. Okay. That's enough fun for today. Goodbye, Swivl.